In this lesson, we'll look at services, one of the four Android component types. Services perform long-running operations in the background that do not have a user interface. This is a page from the developer's website on services. You can reach it through this link on the graphic here. In this lesson, you'll see a service in action and learn the concepts you'll need to develop a service component. The reason we're doing a concepts lesson on services before we examine actual code is that there are quite a few classes and methods used to get a service fired up and running. With graphics explaining the concepts side by side with code, you should be better able to understand the code than if you just looked at the code by itself. But before we study the concepts, let's see an actual service app in action using Eclipse in the emulator. We'll use a sample app, shown here, to demonstrate a service. The app is included in the working file samples workspace. I suggest you watch this lesson first, then open the app yourself and run it in the emulator as I'm showing here. We'll be studying the code in a separate lesson. And the name of the app, as you can see here, is Service Example. This screen is the display for an activity that we'll use to start and stop the service. I'm calling this screen and this activity Service Interface. We see the message below the buttons created by the Service Interface activity that the service isn't currently running. If I click Start Service, we see a toast that the service has started, and then the message Service Running. If I click Stop Service, we see the toast Service Stopped, and the message Service Not Running. Now we'll look at the concepts behind the service, beginning with the objects used to implement a service. This graphic shows the objects used to implement a service divided into two groups, those used by the service interface and those used by what I've termed service execution, which is the actual service component. The service interface is an activity component using objects we're already familiar with. We've used these in previous lessons. We use the setContentView method to create our initial screen display. We use the FindViewById method to reference the buttons in our screen layout XML. We use onClick listeners and the onClick method to execute code when the buttons are clicked. We use explicit intents to start and stop other components, in this case, our service component. And we've learned how these methods are executed in a thread within a Linux process. So this service interface is a nice little review of some of the key capabilities we've learned so far. In the service execution group are the objects that are really new to this lesson, although we have previously looked at threads. The purpose of all the service objects is to manage the execution of your app-specific service tasks, in which you might do something like access the internet. So one way to look at all these other objects is that they're overhead to make your app-specific tasks happen when, in our sample case, the Start button is clicked. So here's how it works. The main class and object type is service. In the sample app, I've called it Service Execution, and it's the object referenced in the Start Service and Stop Service methods used in the interface activity. Within the service, the main objects are the handler and looper. They work as a team to manage the actions of the service, the thread, message queue, and messages. The Android system uses messages as a mechanism to trigger service starting and stopping. The looper, which helps manage the message queue, is actually managed through the handler. So the handler is really the main focus. In the code, you'll see that we'll be referencing the looper object, but its real work will be managed by the handler. The handler and looper provide the capability to run multiple tasks on a single service thread. They use these classes and methods, they're listed here, which we'll see in action in the actual code. Note that it's the handle message method that will hold the code for our app-specific service tasks. So the name is a bit of a misdirection, but this is the name that was chosen, and it refers to the fact that it's the message that's triggering the execution of your service code. We'll also use the handler to create and manage a service execution thread, separate from our service interface thread here. As you recall, threads are run in a Linux process. the handler will use a message queue to keep messages in an order, which are used to initiate service actions. Now on to looking at the sequencing of execution of these object methods. This graphic shows how using the buttons on the service interface trigger various methods in the service interface activity and the service execution component. The graphic shows the highlights to give you the big picture of how it all fits together. We'll be studying all the details in the lesson on service code coming up. The service interface and its thread control the user interface, displaying the text and buttons. And the service execution component and its thread run in the actual background service. First, when the service interface is started, it uses the onCreate method to display the user interface we see with text and buttons. It also sets up onClick listeners here and here for the start and stop buttons. When the start button is clicked, the onClick listener does a couple of things. First, it starts the service, which causes the onCreate and onStart command methods in the service to be invoked. Note that this is the onCreate method for the service, which is not the same as the onCreate method for the interface here. The onCreate method in service execution is invoked the first time the service is started. It sets up a service handler with its handle message method. The onStart method toasts service started. A message is then sent to the service, which is processed by handle message, which toasts the service message text. And note that even though the service can't use the user interface of the app directly, it can toast above the user interface as we saw in the lesson on toasts. And finally, the onClick listener displays the text service running on the user interface. When the stop service button is clicked, its onClick listener is activated, and it displays the text service not running, and it uses the stop service method to stop the service, at which point the onDestroy method in the service is invoked, which toasts service stopped. So that's our overview of the concepts behind Android services. In the lesson on services code, you'll learn how to program these capabilities in Java and XML.